All right, looks like we got a good group. I guess let's get started. It's close enough to 3:30 that I figure most people have managed their way in, and others will join. Thanks everyone for participating and coming to this event. As we've mentioned before, and we've been recording them, so hopefully we're able to find a way to distribute them in the near future. The whole point of all this has been to help everybody expand their toolkits. We've talked about Amazon Web Services and Google Colab and Python. This week, Mark Ballard is talking about SQL, and next week, Donnie Keeley is talking about RStudio and geospatial workflows. We'll try and keep this going for a couple of more webinars. And hopefully one day we get back to in person and can kind of glad hand with each other and help everybody get to know each other's faces a little bit better. But certainly look up and down the chat list or the participants list, and you'll find some really great people that probably many of you know, some of you don't. You guys should all get to know each other really well because you're kind of the experts that are going to help lead this industry to a new era of something better. So with that, I'm really glad everybody's here. Really excited to get started and see what Mark has to show. A couple of comments at the end and some time for Q&A. So with that, take it away, Mark.
All right, thanks, Kurt. Yeah, thanks for everyone coming. I'm going to share my screen here in a second. Let's see, let's just pull that up. There we go. Okay, can you guys see that? Not yet. Yep, good. Okay. Looks like a PowerPoint screen. Okay, so yeah, my name's Mark Ballard. I'm an engineer. Currently working at Crescent Point Energy, and I'm the engineering lead of business intelligence and data architecture, which basically just means I get to play with data all day, which is a good thing. So my background, I worked in as an operations engineer for a short bit, and then most of my experience has been kind of a reservoir / development kind of role. But as it relates to SQL, I started learning it probably 4 or 5 years ago, and it's been kind of gradually increasing as we go. So let's jump into the agenda here. We've got some definitions, kind of define some concepts within a relational database, parts of a query, talk about a table versus a view, and then do a demo at the end in SQL Server Management Studio. So to define the scope of the presentation, in scope, again, concepts of a relational database, talk about keys, like a primary key and a foreign key, and then talk about the difference between a table, a view, and a materialized view. And then this is all the SQL run through is for read access permissions. So that'll be things like selecting columns, filtering, aggregating, joins, and sorting. Not in the scope of this presentation is SQL scripts for anything for write access to create or modify views or tables. Some of that's a pretty simple logic to create a view, but we'll stick to the kind of the basic SQL operations, and then the last part here, just putting on a few things that maybe you can go Google later. Like, okay, now I understand the basics. Here are some things that I can figure out, like window functions are for calculating running totals, that kind of thing. Usually I'll do a lot of subqueries within my own scripts, that kind of bottom one there, but in case statements, but loops and the running totals and all that fun stuff we'll leave to RStudio or some kind of BI tool. So we'll walk through some definitions. SQL stands for Structured Query Language. I guess an interesting thing, a lot of people are kind of sticklers with pronunciation. The first kind of book that I bought to start learning SQL, they actually were clear to say it's pronounced SQL, and SQL is just the term for Microsoft's Microsoft products, their system. But I hear people saying SQL or SQL kind of intermixed, and so I'm going to run with SQL. But do as you please. So why is it used? The simple thing is just it's interacting with the relational database. I'll go over some use cases for that, and you'll understand a better meaning for it. So working our way down to a relational database is just a collection of tables organized in rows and columns. Again, if you Google that, you'll probably get paragraphs and paragraphs describing all the ins and outs of it, but that's kind of the simple way to look at it. And then a few examples of relational database management systems. Microsoft SQL Server and Oracle are probably the big ones that your systems of your companies are built on. SQLite is a common one that has a lot of databases kind of built on that. And then these other ones are also somewhat common as well. And then one thing to note, but between each of these systems, the SQL syntax is slightly different, and there are certain functions that only work in SQL Server and only work in Oracle. And I'll try to keep it as generic as possible in this. And we'll be using the database tool from SQL Server, Microsoft's product. So they have a few things in there, but again, we'll try to keep it basic so it'll apply to all the systems. So use cases for SQL, there's probably a ton more on here, but these listed here are my main use cases. And it's never an end game. It's always just getting from A to B. The first one on there is importing data into business intelligence tools. So these are three that I've used, probably Spotfire the most, and Power BI more frequently lately. ClickView is another one out there that people use. So that's one workflow. The bottom two are little example scripts for R or Python, and the idea being that their script in red is just the piece that you would use. So you would reference some library or package, set up some kind of connection via ODBC or something like that, and then you have to reference your script. And so what we're going to be going through today is that kind of red piece for what all that means. So to dig into a relational database a little deeper, you've got rows and columns, right? So the rows, you've got specific data types within a column, and so it can be a text or a number, integers, decimals, that kind of thing. The rows are the deals there are you have to have a primary key, which is set to a column, but it defines a unique row, and so that you can separate all the rows from the other ones. Foreign key, it basically defines a relationship between tables. There's a lot more rules to both primary keys and foreign keys, like you can't have null values, you can't I don't know. There's a ton more with foreign keys there, but I'm not going to go into that. Just kind of know that it just helps you know what table you can reference back to another one. So if I'm looking at this is a header table. You've got 5 columns in it. You've got an API, well name, field number, location, and an operator number. The primary key in this table would be the API number. You can't use well name as a primary key because there are duplicate well names. And again, the definition is you have to define a unique row. The same for the field. These are both duplicates. Location, there's duplicates. It looks like operator, there's also duplicates. So none of these work as a primary key. Just the API does in this example. So database tools actually query the relational databases. Today I'll use Microsoft SQL Server Management Studio, or SSMS. I think SSMS is free. I don't know that. you pay for SQL Server, but I think the actual database tool is free. Okay, someone did comment. There you go. SQLite X or Expert Personal is free. dbeaver, DB Visualizer. These all have free versions and paid versions. So just a couple of tools out there. Okay, so now let's dig into different parts of a query. So first we'll start off with the top part, just grabbing columns and specifying tables. So in the select statement, you got select star, select asterisk. So this asterisk just means you're going to select all the columns in a table. Or instead of an asterisk, you can use, specify which columns you want. And we'll go through a ton of examples for that before long. And then from the from statement, you just say from a table. You could just do one table, or if you have multiple tables, you have to specify what column matches in each table to connect everything. And again, we'll go through more details on this later with some diagrams as well. And then digging into the rest of it. So the where clause, I'll have another separate slide for this as well, but the where clause is just specifying row conditions. So how are you going to filter your data? You want everything by a certain operator, or oil production greater than, I don't know, 1,000 barrels a day or something like that. The group by, you only use this when you're aggregating data. So let's say you have a table full of production. So there's a ton of API number is duplicated for every month you have production, but you want to know the sum of production by that API. You would specify that you would want to group by an API number, and then at the very top at the select statement up here, you would specify you want to sum oil production or something like that. The having clause, I won't get into that too much. But you can use it to say, like, I don't know, let's say you're summing oil production by well, and you only want to actually query the data that has an oil production greater than a certain amount. So you can't set that in the where condition because it's something you're aggregating. So you set it in the having. So it'd be like having count or sum of oil production greater than whatever your number is. And so again, you would put it in the where statement if it was for an individual month, but if you're doing any aggregating and you want to know for the aggregated amount, you would put it in the having statement. And then the order by is just for sorting. Okay, so now we'll talk about joins, and there's four main types, and I've got a Venn diagram here showing to help kind of walk through each example. So imagine here you've got your header table that we showed from the last slide that's got one unique row per API number, and then you've got a production table that has a unique row per API per month. And so you want to merge those two together to do some kind of analysis. Different ways you can merge it. So an inner join is looking at only the API numbers in both the header and the production table. A left outer join is saying, okay, let's do everything in the header table and only the API numbers in the production table. The right outer would be the opposite of that. And then the full outer would be, okay, do we have wells that are in the header that are not in the production, and the production that are not in the header? You'll merge kind of all that data together. And then, so here are some kind of operators for your where statement. So again, we're talking at after you specify your tables, you want to limit your data set by something. You can use, so here are some kind of comparison operators for numbers, or for text, I guess, for this as well. And then some more text operators. The most common one is this one in the middle. So where operator name So that's our column, and then like. So this logic here is just saying, give me any values that have or in any position. So that's probably your most common one, unless you know it's this one where it's it starts with a. That is one one way to use that. So we'll walk through some where clauses in the demo as well. Okay, so now let's look at the tables we're using in the demo. There's a header table, a field table, table prod, and table operator. So we've got 3 million rows of production data across 30,000 wells. There are 190 rows specified and 230 operators specified. So we can join all the tables together, and this is kind of the end game. You want your data probably for your analysis to have everything all in one table, and so this statement, I'll kind of walk through this. So this select star is just grabbing all the columns from all of the tables specified below. I'm saying from table prod, and I've got an alias on it, just P. So grab everything from table prod, I'm calling it P, and that'll be useful for these next lines. Let's join in the header data. And one thing to note, the order does matter here. So if I go back, you'll notice that operator number is not in the production table. So here are we, production table. So we don't have a field number or an operator number in there. Those are in the header table. And then the field name is not in the header. So in order to join all these together, you need to work through in steps. But once you've joined in, so we'll start with prod, and we'll join in the header. Once you join that in, then you've got all of the columns from these to work with, and you can join in. Whether you join in field first or operator first doesn't really matter. So we'll join and I say join, you can type inner join as well. It does the same thing. So join table header, alias says is an H, and then what columns am I matching? So header, so this h.api I'm matching with production table.api. So then the second table we join in is the operator. Again, it could be field or operator at this point because you already have all of these columns to work with. I'm aliasing this with an O to operator num equals H to operator num. So once it's all said and done, notice that the order of the columns are the order at which the tables are joined in. So prod is first. These are the first 5 columns, and then header, and then operator and field. So you can specify different order just by selecting the columns individually if you choose to do it that way. So before we get into the demo, I want to walk through a few more terms. And since I've introduced the data set, I just wanted to put it in at this point. So talking, again, these aren't going to matter so much for the demo, but they might affect your kind of day-to-day. So talking about a table versus a view versus a materialized view. So a table is just what it sounds. It's just a collection of data organized in rows and columns. A view is a common term that everyone throws around, and all it is a virtual table. You create it using a SQL query of whatever criteria you specify. But the deal with a view is that there's not actually data stored with it. It's just there's no kind of material in there. And then a materialized view is a view that's stored in memory as a table. So the difference between a materialized view and a table is just that the materialized view, you can set that to refresh, daily, hourly, whatever time frame you want, but it's something that is stored in memory. And I'll talk to that a little bit more below. And so this data here can be represented here by a view or a table. It really doesn't matter. It just matters how much kind of space it takes up. So this last one, why use a view over a table? I took all of the data and just exported it to a CSV. I joined everything in one table, like this one here below, and that's in blue. And then in these bars, these other colors are kind of blurry, but summing all of the size of all those tables up is only 86 megabytes, and then joining everything together and storing it that way is 345 megabytes. So that's why these relational database architectures all have everything separated, because it's much more efficient to store your data that way. There's pros and cons to doing it in both ways. The issue, I guess, the cons against when you're trying to load your data into your RStudio or your Spotfire or Power BI, your load times are going to be a lot longer if you're just connecting to a view, because there's no data there. It's just it's processing all your joins, and it's building your data out. Or on the flip side, if you're connecting to a table or a materialized view, that does take up more space on your database, but it's going to load a lot faster because it's not doing any of the processing of the query itself. So that is what I've got for the slides, and now we'll jump into a demo, and I got to log in. All right. So I've got SQL Server Management Studio pulled up. If you were to pull it up, and in most of these, you've got this kind of Object Explorer here. I'm just going to hide that for this purpose, just because we don't need to see it, and I've got some other stuff in there too. So I've got a list of things I'm going to run through, and in the green are the kind of the notes for things that I'm going to type out, and we'll just kind of work our way through it. So the first one, just select a single column from a table. So I will just do select API from the header table. So I'll highlight this. I'm going to try my hardest to not hit F5 and actually use my mouse so you guys can see what I'm doing. But I run that query, and my results are below. You can see the row count here. So the rows that you run and how many records are pulled in each query kind of vary from database tool to database tool. Some of them you can there's a setting where you say only display 100 records. Sometimes you can use a function to limit the amount of rows in the query, but I won't use that here because it's different for each kind of database system. So okay, let's grab multiple columns from each table. One thing that I do like about SQL Server Management Studio is if I specify the table first and go back and start typing in columns, it'll give me a list of the columns as I start typing them. Okay, so now we've got multiple columns. So it's just select the column name, comma, and then run. So that's pretty straightforward. Okay, let's looking at unique values in a column. So I'm just going to pull up. Before I do that, I'll just grab all of the columns in the prod table. Not that one. Prod table. And if I run this, okay, so we have 4 columns here: API, production date, gas, and oil produced. So the idea here now is, okay, let's just grab the unique API numbers. So you can use the distinct function. And so to select distinct API. Okay, so now if I run this, I would just get all the distinct API numbers. Again, it's nice that this count here is in the bottom right part of the screen, showing that I've got 29,000 rows in this query. The same thing, you would set up this query the same way for looking at all the unique production dates, and you would just change out API for prod date. So you can also order the prod date just by, and I should probably keep these in separate lines for you guys so it's easier to follow. It doesn't matter how you do it all in one row or separate lines. So now this is ordering by prod date. I've got a comment in here just so you guys know too. So the prod date's actually stored as a text, not as a date. We won't run through how to change it using the cast function, but that is something that can be done. So this is just treating everything like a text and sorting it that way. Okay, so now let's run through. Select all the columns of all rows of a table. So we've already done that, right? Again, that's just using the asterisk there. Okay. So now these are all the columns in that. So now let's jump into doing some aggregating. We'll count some records. And you'll notice just the big difference here is just from what we've been doing. You have to, if you're going to show it, counts by operator or counts by other things, you've got to add something in the group by. But you don't have to have your group by clause if you are not grouping it by anything. Okay, so count the number of records in the production table. So let's go select count from table prod. Okay, so this is, now it's showing me, okay, my count is this 3.2 million rows. I can add a comment there if I want to. Count is this, okay? Again, if you put a comment in your script, it's not with the two hyphens, it won't ruin anything for you. It's just kind of a note that you can have there. I've got a couple more of these. So let's see. Count the number of non-missing records of well name. We don't have any non-missing records, but I guess I should probably, I don't have well name in the table, so use API. Select count API from. Okay, so this is going to give you the same count as before, just because there aren't any null values of API number. But if there were nulls, this would that would show up here. You would have a smaller count. So then count the number of unique wells. So we could do a count distinct on API. Let's see, I probably need some parentheses here. Anyways, yeah, so where's my mouse? Okay, so now this shows that number should ring a bell. There's 29,000 distinct API numbers in the production table. Okay, now let's do some well counts by operator in the header table. So let's just look at the header table again so you know what's in there. Okay, so in the header table we have this operator number. We don't have operator name. I won't join it just yet. I'll just kind of show you the syntax without first. So let's do select count. We could do API or, well, it doesn't really matter, I guess. From the header table. And then I said, oh, sorry. I'm counting the API. So so if I run this first, this just gives the count. So now if I put in operator number, this will give me an error message because I don't have anything specified in the group by. So in this case, I want to group by operator num. So here, just kind of notice that if you want to have anything else to group by, it has to be both in the select statement and the group by there. And right now it says there's no column name for the count, so I can just alias that. You can either run it like, let's just do, whoops. Put a count in that way. Cool, and that's count 8-bit. And then, or you can have an as statement if that helps you go back and read through your scripts. So again, those kind of do the same thing. So now we've got a well count by API. Excuse me, by operator. So now, okay, let's count the wells per operator in the header table, and with add a sorting. So I'm just going to copy this while we're here. All right, let's do. We can order by operator number, but that's not really all that meaningful because I don't know. We don't really know the operator numbers, but I can run this, and this is sorting the number. If I want to add in the operator name, let's do that. So I can do a join and say join table operator on table header dot operator number equals table operator dot operator number. Okay. And so now it's smart enough to give me some errors to say, okay, you are operator num. We don't really know what that is. So if I run this, I get some kind of error message because operator number is in both the header table and the operator table. So in the select clause and the group by, you have to specify which one. So let's add it to the select first. Let's just, we'll go from the header, table header dot operator number, and I'll put it down here as well. Okay. And probably here, let's see. So now let's run this. Oh yeah. So then my other thing, so I've joined it, but I didn't specify that I wanted operator name. So let's just add it. We can either replace operator number or I can just add operator name. We'll just add it in addition to it. So and grab that. And again, since it's in the select statement, I need to specify it in the group by. And I'm going to change my order by to do it by the operator name.
Need the comma after operator name on the first row.
Oh, look at you. Paying attention. Thank you. Oh, cool. All right. Well, anyways, this is good. Now we can work through this together. Okay. So now we've got from the top, we've got the header dot operator number, the operator dot operator, the operator name, and then the count of the wells per operator. This one is just a data bust. When I was importing the data from just a comma delimited file, anything that had a comma in it kind of shifted everything over a row. So anyways, you can ignore that. Yeah, so this is sorted by operator name. Kind of going through, you can see those counts. The one thing that I had done in the slide deck was to alias the table, so I'm just going to do that real fast. Copy and paste this. So if I rename header and alias as an H and the operator as an O, I'll just change these guys real fast. Oops. Okay. Sweet, already messed one up. Okay, so this is just cleaner to look at. You can alias things however you want to alias. It doesn't have to be one letter. It can be two, or as many as you want. It's just a way to kind of clean up your script. And so if I run this, I get the same. Cool. I don't get the same thing. And I didn't specify my join. Okay. Okay. So if I run this, I get the same thing if I do it right. Okay, and now we can run through joins. I've kind of already mentioned a couple of things here, but let's see. Combine all the wells that are in both header and production by well name. Okay, so again, let's look at everything in the header table and the production table. Alias production table, and then in the join, it doesn't matter which table you go first. So you could do the header first here too. Equals p dot. Okay, so the other thing, caps don't matter. So in here, this gets the same result even though API is capitalized in production, but it's not in the header table. You can specify, let's say if I wanted the header details to be first, I'm just going to copy this. And, well, I guess to get the same result as before, you could also do p dot star and h dot star, and this gets you the same result. If you want the header data to be first, you can do it first. Okay, so now we've got the header data first and then the production first. There's a lot of rows here, so this is just taking a while to execute just to bring in all the data. I'm just going to stop the query. What are other examples I was going to show here? Yeah, so again, all of this I've kind of already shown you. I was going to show just you don't have to alias, or you can alias if you choose to. If you want to look at all the wells in the header table and only the ones in the production table that match, just how to actually write a left join. You can, I'll just kind of show you how to make it work. For this, purpose, it won't show any different records because every API number that's in the header data is also in the production table. But let's do a left join table prod. Okay. So this is in your kind of Venn diagram, the left part of it is the first table that's mentioned, and then the right side is the second table that's mentioned. So that's probably generally a good kind of practice to, or just something good to know, I guess, there. Okay, let's look at all the records in the production table where the operator contains noble. Okay, so I will grab everything from production table, but to get to the operator table, we have to join in the header table first and then join in the operator table because the operator number is not in the production table. So let's join API. Okay, and then let's join. So inner join and join both do the same thing. So let's bring in the operator table. Call it O and O dot operator number equals H dot operator number. Oh, man. Ahead of myself. Okay. Okay, so now we've joined everything in, and then I want to specify where the operator contains noble. So we'll do a where, and we'll do O dot operator name. Like, oops. There's nobles anywhere in the name. So if I run this, again, I've only specified just everything from the production table, but this brings in all the data, and that actually already finished. There are 391,000 records there. If we want to put in, maybe let's put it in before. Let's go O dot operator name. Okay. Okay, so now you've got operator in there. Okay, now we'll do some text functions. I'll show you a bad join, and we can open it up for questions as well. So looking at the header table, just again, the API column only has the county and the well. If we wanted to add in the API 10, you can use the concatenate or concat function, and I don't really know the state code. I think that's it for Colorado, and then API, and I'm going to name this API 10. Okay, so now I've got all the columns and then this formula. So concatenate is, again, just kind of joining text strings together. That's one thing you can do. If you want to make one without the hyphens, you can use this substring function. Substring is sometimes just str in different database systems, but again, I'll just copy this one and maybe do it in pieces. We'll do, so if I just want the county, substring API, so it's a starting position and ending position. So I want to start at the first character and end on the third. And this is API county. So if I look at this, okay, so now we've got our, we've got our API county listed here. Probably don't need all this. Let's just do this. Okay, so I run this API 10, API county. You do the same thing with the substring. Let's do it again. API in the starting position here is 1, 2, 3, 4, 5, I think. 4, 5 characters in API well. Okay, so now we've got the API well, and then you can bring everything together all in one kind of big concatenate function. So I will just type it out. And I'll just copy these other guys. Okay. So this should work. Hopefully I didn't skip anything. Oh, yeah. So now it kind of shows you how to work within some of the text functions, and there's a lot out there, and you kind of work your way through that. The last thing I want to comment on is just a bad join example. So in your joins, you always want to make sure that there's at least a primary key that you're joining on, or something that defines a unique row. So if I do select count star from the production table. Okay, so this was like the 3.2 million number. Okay, let's just write that down. Count is this. Okay. And then if I join the production table to itself on API number, that is going to be an issue because we'll just call this one P1 and the next one P2 because the API number is duplicated. So P1.API equals P2. Okay. So now there's, I don't know, millions of records. So just make sure when you're doing your joins that you know, maybe you're doing some count stars on tables and trying to understand what the primary key is before you're doing your joins. Because this is a many-to-many relationship and it kind of screws things up for you. So I know that was a lot, but that is what I've got for today. You guys have any questions?
That was great, Mark. When you're using SQL, is this the Microsoft SQL user interface that you're working in right now?
Yeah. Yep. This is.
Does your SQL interaction, like it's all the same if you're in different platforms or different environments, right?
Yeah, it is. Hold on a second. Cool. Cool. My 1-year-old found some pliers, so my 3-year-old was bringing it to me. Yeah. So no, the functionality is not exactly the same.
Okay.
The autofill, like when you specify the table name and then go back and select your columns, just what columns are there, like that isn't really there and helpful for you. But most of the other part is like adding the comments. That's all the same. It carries your kind of syntax through. So that's generally all there too. Yeah, Matt just made a comment on the chat there that MySQL as a workbench and Language is, yeah, it is different for pieces. A lot of what we covered today shouldn't be different, but there will be differences once you get more advanced.
That's kind of what I've run into with using MySQL or MySQL, trying to build a database. Is anybody else using SQL or using software they know is related to SQL and have some comments on how they've interacted for it or how they might have paired this with some of the other languages or things like Python, R, Spotfire, Power BI, Excel?
I was going to say that just this morning, coincidentally, I got installed this Azure Data Studio. I don't know if anybody has used that software before, but apparently it's also a Microsoft product as an Azure product, but it seems really similar to like VS Code for SQL. So it's kind of seems like it's supposed to replace the SQL Studio, Management Studio, if you're not really doing like database admin tasks. If all you're doing is writing queries and looking at data, then it's supposed to be a much better tool. But I haven't tried it
yet. I have not either.
Yeah, it's a free tool, and just download it, and it looks pretty slick.
That's a question to anyone working in PostgreSQL. Are there only subtle differences from, Mark, what you showed today, or are there larger differences in Postgres versus standard SQL?
You know, I haven't used it a ton. Again, for the basic operations we're doing today, there's not really a huge difference. It's more when you get into writing more functions. I don't know, like as a simple example, like in Excel, you've got your left and right text functions. Those are definitely there within SQL Server, but I'm not sure that they're there in other operations. You might have to use substring and some combination of that to get you what you need. So Google always helps too.
Yeah, I've been working with, there's some Python tools for like interacting with SQL databases, and they basically work by sending commands to like a SQL, I guess, shell of some kind. But trying to, for me at least, it was a learning curve and trying to understand how the commands work. But then once you get it into another language that you're more familiar with that might be better suited to the analysis, you kind of try and use the right tool for the right job. And SQL is definitely a good one for the relational tables.
Yeah,
for me, using, Kurt?
Excuse me?
What tools were you using? You said you're using some Python tools?
Yeah, I can't remember what the package is. I'd have to go.
SQL Alchemy or?
Yes.
Yeah. I haven't used that one, but I've used PyODBC.
Yep.
And CX Oracle. If you're connecting to Oracle, it works really well. And like you said, it's kind of like do the right tool for the job, because you kind of can have think about like the right tool for the job is kind of in a way the tool you know better. Sometimes that's good for you and sometimes it's not. But like if you're really good in SQL, then you don't need to know as much like data organizing in R or Python. But if you're not that good in SQL, if you're not that good in SQL, you can write a really basic SQL query and then just kind of massage your data once you get it into another tool.
Yep. Mindy, do you have anything you want to add? Because I think you work in SQL more than I do.
Yeah, we are pretty much 100% of our data that are structured data that we use in our different BI and scripting tools sit inside SQL Server. So our data warehouse is all done in SQL Server, and we have tons of different tables and views and stored procedures for all that data. So Mark went through today is very familiar to us. A lot of it as Mark showed, just kind of, writing it out yourself. There's also some tools that you can use, like backend tools that help you design what you want it to look like. So it's more drag and drop functionality, and you can tie identifiers to each other a little bit easier and do some validation. But, SQL is great, especially when you're comparing it to some like Oracle and some of the other database management platforms. We have a couple of our data sources that are either hosted or the backends to those, like Quorum and General, are Oracle. But we actually move that data. You can do like link servers to those data sources, and actually we pull it all into SQL so that we're all in standardized platform.
Hey, Mindy, do you guys pull that into, this is Zach, do you guys pull that into SQL manually, or are you using Welland or something along those lines?
Yeah, so we're not using Welland. We are using various APIs. We're using the link servers. You can actually go in and basically just connect directly through there. They'll give you a URL for some of them and a username and password that you can use. But we're not paying for any third-party tools to migrate different data sources. But platforms like Wellview, if you have the Peloton suite and they're hosting it for you, you can use their Peloton API to actually write data back in as well from SQL into those platforms. But Welland and like SQL Connect, those are going to be more if you would have to use some of those if you had like a Unity. But if you're using just a normal Oracle or SQL platform, you wouldn't need one of those tools.
Yeah, we use Welland to connect to our Unidata Bolo.
Yeah. Bolo, yeah. Bolo is pretty much like the only one that's still used today.
Well, I've heard of some other people using Welland for Oracle and some other stuff. I wasn't sure how common it was.
Yeah, I think it might help with some of the organization aspects of it, but I don't think it's not necessary.
Well, this certainly has been good for me trying to get a better sense of how to use SQL. I'm pretty much a novice in it and trying to figure out how to store things. And I know some of you guys, I think Matt, you might be trying to build some SQL databases with all the scraping and compilation of work that you've been doing recently.
To date, I have indexed all of the last files from the Colorado oil and gas. I've got frac focus there. There's something else I have. But yeah, if you can get it and kind of index it together, it works really, really phenomenally. To do logs like I was thinking of doing, I have to have the API or the file along with the depth, along with each curve individually, just to kind of stack it all together because column-wise, it would be completely different if you by depth or the curve. So it does have some drawbacks when you're looking at it like that. It has to be fitted into that flat rows and columns kind of idea.
Yeah, I think that gets you to like thinking about things relatively. Like with production data, I think when you bring that into SQL, you often do it by relative absolute date, and trying to think about what's the most efficient way to construct the database.
Oh, exactly.
Well, so much, Mark, for giving a talk today. I think next week we'll be talking about RStudio and some spatial analysis work that Donnie Keeley is doing within Cana or Ovintiv now. And he'll be presenting on that again next Tuesday. And then we'll probably send an email out shortly. I think we're going to try and start a book club of some sort quarterly and have some discussions about books that to some extent promote better thinking about how we construct our organizations, consider data, make decisions, things like that. Early days, I'm trying to figure out exactly how that's going to go, but look for a comment about that. If there's books that you're thrilled about or would like to even present on to kind of conduct a conversation around, we'd love to have you involved. But we're just doing that, but that'll probably be a quarterly thing. So we'll do that next quarter. So with that, thanks everyone for joining.
Hey, real quick, Kurt, sorry.
Yep.
One other thing, one of our other upcoming discussions that we're going to have that interests everyone, I've been looking into a little bit more and then chatting with Alec Walker, who's on the call right now, is around natural language processing, NLP, and using data science and different machine learning techniques to help with that processing. So Alec is actually offering a class coming up here in a couple weeks as well around that. So Alec, do you want to just give a quick kind of intro and discuss some of what you're doing, what that class entails?
Sure. Yeah. Thanks so much, Mindy, and everyone else for giving me a little time. So I'm excited to maybe hop on this later on if there's a chance to host one of these, and it'd be fun to cover some data science methods, and maybe some of those could be overlapping with what's commonly used in natural language processing. It's not really, this is the second one of these that I've joined, and I see a lot of people talking about how to handle subsurface data specifically. Natural language processing obviously is about handling the unstructured textual data. So slight.
We all have land teams.
But yeah, so we could cover some of that stuff, and it's kind of, programming language agnostic. Maybe we could do Visual Basic or Python and just talk about some of those things. The upcoming course, separate from this group, I'll paste the link. Typically what I've done in the past is just offered courses like this for corporates, and sometimes for the big professional societies like AAPG or SPE or something. And just given what's going on in the world, I thought, why not just open it up to people generally? And so that was kind of the impetus there. And the goal is to cover what's going on with automating workflow processes, and how can people get better at that generally, and also how can we use data science and machine learning to drive decisions in the workplace using references to real data and make that a transparent process. Those two things really get people ahead in our industry, and that's been true for my 12 years in the industry, and just see it more and more true. So that's kind of the goal of the course there. Really welcome any feedback, because it's actually the first time I'm offering it to the general public that way. And then, yeah, I guess the other thing to talk about, the natural language processing piece, is it'd be fun to hop on here and show some of what that looks like, and maybe show a demo of a tool, and then give some suggestions about how to build that kind of stuff yourself. So there's a lot of low-hanging fruit there, even though to make something really comprehensive and powerful takes a lot of time.
For sure.
Awesome. Thanks, Alec. And the link is in the chat if anyone wants to take a look.
Thank you.
Yeah, we were going to talk here about, or we had talked previously about maybe doing some things on text recognition and some of the ways of getting data out of PDFs and sort of the static files, getting them into databases. And that's where natural language processing also has obvious recognition there. And yeah, there's some real fun that can be done. The technology keeps getting better and better. It's pretty impressive.
Yeah, that could be a cool topic as well. I think cleaning up the OCR, often what you can build that is domain specific does better than the off-the-shelf tools. So there's room to do some pretty cool things there.
Excellent. Well, we will definitely have a talk more on that focus in the future.
Charlie.
Hey, Mindy, thanks for putting
Good.
Quick comment, guys, if you don't mind. A little selfless appreciate Mark for your discussion today. Conduit recently got into the Unidata server stuff. So I know you guys mentioned Welland, but Conduit also currently has a conduit for Bolo. That is the cloud-based version, and if you have the on-prem Unidata servers. So that is something that we do manage now and provide into like a SQL environment. So just thought I'd throw that out there, and thanks, Mark, for the discussion today.
Cool.
Good point. And also, just along with all the database, maybe somebody can present at some point on, spatial database, your SDE, and what that looks like. I know Charlie has a lot of experience in that, and others on this meeting. So kind of opens up a whole nother realm of that database management. So
yeah, cost benefit analysis of data virtualization, but there's a lot of hype around data virtualization using like things, discussion around that, maybe some use cases, and basically whether it's worth it or not.
Mm-hmm. Yeah. Agreed.
Okay.
Perfect. That's everything. Well, thanks, Mark, again for the presentation. It was great. And thank you, everybody, for joining. And we'll send out an invite for Donnie's chat.
Sounds good. Talk to you guys later.
All right.